this year in 2024. A lot of writing to do before then, but I took this opportunity. I am presenting a webinar next week, so thought this would be a good chance to quick run through this. Some of you heard varying parts about my project over the years if you've been here for a while, so we do have some new developments, so just try to run through a quick overview of it and where we are now. So the webinar that I am helping with next week, one of three speakers is the upcoming models and tools to improve manure management. And we're talking about ManureDB, our manure database project we're working on here. So just a quick overview, livestock manure provides nutrients for growing crops, but also overapplied can be an environmental problem. A lot of the reference published US manure book values are over several decades old. So if you wanted to look up some turkey manure, what is the nutrient approximate concentrations, you know, they'd be probably from the late 90s, early 2000s. To help look at this, some researchers, my advisors, Dr. Melissa Wilson and Dr. Cordes, received some grant funding for this manure database project. And we are partnering with laboratories and universities across the US on this endeavor. And big excitement is we have a public website and data download now available. A quick overview about how the project was structured. We're actually partnered with the Minnesota Supercomputing Institute, one of the researchers and developer over there. We have a stakeholder group, people across the country. What goes into the database itself, we have the schema organization of it, the actual database part, and then also the public website. Big part of this was working and recruiting labs to participate in this project. We don't have any samples, it's not really much of a project. So a lot of that was recruiting them. Also then going through data, cleaning them, standardizing them to go into the database project. And today we have over 489,000 samples in the database. So a little bit about our project team, different livestock commodity groups, regulatory people, researchers, engineers, and professionals, alternative energy groups, and commercial manure laboratories. Along, of course, with Minnesota Department of Agriculture and Extension CFANS and MSI. A big part of this with a lot of data, big data things in general is privacy. We do have a 2-page data use agreement we have between the laboratories and the university signed. We don't want any customer names or addresses. We can import the first 3 digits of a zip code to even aggregate the geographies even more. But also to help maintain privacy, we need at least 5 samples per animal type per year per geography to show up in the summary. So if there's only 1 turkey sample in North Dakota, you can't like go back try to find that. It has to at least have a decent quantity to show up in our summaries. A big thing too, as you can imagine, working with all these different laboratories is that they have all kinds of formats for their data, call things differently, units are different, methods, what they call an animal may be different depending on what it is or how much detail they have. So we had to kind of come up with a standard template. Really the only things that we do require is that what year was this analyzed, and if we can have the animal type or other amendment. At least those as a minimum starting point. We can have lots of extra things. Again, we really like to have some sort of location, especially state if possible, any notes. And then we also have manure treatment, agitation, bedding, storage type, length of storage, application type, and then our list of all the different analytes possible. So there's just a quick array. I mean, a lot of times you think nitrogen, phosphorus, potassium are the big ones we're looking at, but we'll take whatever people have. So a lot of them aren't that common, but we'll take it if they have it. So here's like the exciting part. This website is now live if you haven't. Take a look, just look up manuredb.umn.edu. edu if you get a chance. We kind of had a soft launch last summer and it's been, going through updates continually, improvements along the way. Even this week there's been updates, so stay tuned there. Current statistics, we've had over 21 signed data use agreements, which we're pretty proud of. We have 9 more verbal agreements, pending signatures. Said over 489,000 samples in it, over 380 to have an actual known location. This all is over 5 million different data points in the database. And we do cover 49 of the states, Puerto Rico and DC. So I'm working on Alaska. Right. Here's just a few screenshots of like the main page that you can see today. You can do some really quick summaries based on different years or states, stored manure types, and different common animal types: beef, dairy, swine, poultry, sheep, or horse. Said this is the really exciting part. As of mid-January, we now have a data download feature. And you can also sort by the different animal types, kind of moisture, region, state, or year, and then download a CSV and then look at the data to your heart's content. So yeah, this is super, super exciting feature that we've been really wanting and working on and trying to hone some of these rules to make happen. While you're thinking about this, like, why do we even want this? Why do we even care about all these samples in this database? Of course, again, any farmer would say, having your own manure test, sampling your own nutrient source is always the best if you can. But this also offers some comparison, benchmarking, different scenarios, to be able to see where you stack up compared to other farms. And then also going to be very useful for research, and I know regulatory people are also interested in it too. So lots of different possibilities. A few just different things we've been able to start pulling out now that we have this data. I'll just give you a few examples here. Like, here's what they were saying about like phosphorus levels in swine manure. That's something I knew in my previous job where I worked at a swine company doing nutrient management. And we could tell from feed additives that they use that the phosphorus levels are lower than what the book values were. We could see that. So here I'm just plotting it out. You can kind of see the trend there downward. Here I'm just pulling out samples of different manure types, which now, if we have enough samples, labeled well enough that we can kind of start to see some different trends. How do things look if they're a separated solid managed compared to compost or something like that? So that's kind of an interesting use. Or if we split out, some samples we just have are listed dairy, for example, but in some cases we have, is it a dairy heifer or a dairy calf or a lactating cow? You can kind of start to see, okay, how do those breakdowns between samples look? And as you can see, we have over 90,000 with regular just dairy, so it's a lot of them. And some labs just have poultry listed as a sample, but in some cases we have more specific things than that too. So how do chicken broilers, compare to chicken layers or turkeys? So, some places they have similar trends, but you can see here, even between the broiler and layer, like the phosphorus level, the triangle in the middle, they're, different ratios, how they are. So anyways, lots of different things you can do, lots of things you can look at, lots of ways it can be done here in the future, and I will be probably writing about a lot more of them soon. Future plans, one of the updates we're working on right now is to make a mobile-friendly version. So yeah, when you look on your phone, it doesn't look quite as disorganized, and looks a little more easier to view. Also trying to work on some better data visualization displays on the website. Also looking to archive this data on an annual basis with USDA's Ag Data Commons. So we're confident enough now in our data set to start that first archive. Moved ahead. Eventually might like to work on having a lab specific login view so they compare their lab compared to other labs and see, are they way out there or kind of trending down the middle. And we're always continuing to add more labs and try to streamline. We'd like to continue to add annual data from labs too, not just data from the past. Like we have we'll take whatever they have right now, but just to continue to keep building this and keep it live and functioning. Yeah, I think I skipped the slide of, I think my advisors and the rest of our team, Kevin Yanni, retired engineer, Kevin Silverstein at MSI, and Larry Gunderson over at the Minnesota Department of Ag. We do have an email list, so if we do have some big updates or something, we'll send out if you want to get on that. Sign up for that. You can always email manure@umn.edu. And then this is just a little plug for the webinar on February 16th that I'll be a part of, along with Rick Stoll of the University of Nebraska-Lincoln and Chris Vanig of My Farms LLC. So yeah, about manure, upcoming models and tools to improve manure management. So thank you very much. If you have more questions, let me know. So thank you.
Do you have any questions in person or online?
Oh yeah.
Can you see how many people are using it?
Oh yeah, we have Google Analytics on it. So yeah, every month we're starting to see, and you can see people from other countries. Yeah, usage. So yeah, yes, we do.
Is there a manure proficiency test for the labs, or just taking any?
Oh, very good question. So here in Minnesota, actually, they're quite up on manure, and Minnesota Department of Ag administers the Manure Analysis Proficiency Program, the MAP program, where they send out samples twice a year, sets to labs, and they analyze them and send them back. And they also help them, let them know if they need to address something in their lab, and they offer a certification program. So their list is one that we really want to recruit. And honestly, most of the ones that we're actually just talking about that today, I think cross-reference, but most of the more popular ones that do manure are participating in that program. So that is a good question. I think we would take anything, but I'm not sure if we have any of that said. We were actually just talking about that this morning. Anything would be, and they do update that list every year too. So and we're looking in the past, so I don't know which labs, which year. But anyway, yeah, there is a proficiency program, and I'd say a lot of the labs do participate in that. And you can see the labs that do. It's on MDA's website if you're interested.
Any more questions? I do have one question myself. Are there any hopes or plans of asking labs to start standardizing things? So instead of just getting poultry, you can actually get more broiler, or not just dairy, but dairy heifer, things along that lines?
Yeah, we've been talking about that, and I'll probably be writing some about that too, I think, in the list, but about what are things that we would suggest to include. And also, again, in some labs, depending on how they write things, can there be a checkoff on their list, like, I'd like my sample to be included or not included in this project too. So I know like a couple labs said, oh, the way today we can't participate. We'd like to, but I don't think we can. We might have to modify our forms as well. Yes, definitely think there's room for improvement. Yes.
Well, that's all the questions. Thank you, Nancy.
Yeah, thanks. Feel free to ask me any questions later.
Our next presenter, I'm going to ask Rory Malone to come up and share what he's been up to here lately.
Bohl-Bormann. Some of you have seen this presentation, some of you haven't. I'm just giving a research update about what I've been working on for my master's thesis. I am working with Lindsay Pease in the Peace Lab up at the Crookston campus at the Northwest Research and Outreach Center up there on a phosphorus fertilizer and rate trial. There's a field trial, and then we create a little lab trial around it. I'm going to go over both. So the motivation for the research, it's from a grant through the Corn Growers Association. So it's focused on creating new recommendations for farmers. But in this area in particular, there wasn't corn, now there is. It used to be mostly wheat based and other small grains. There's also major flooding, and it's in the Lake Winnipeg watershed. So the Red River flows north and all of it moves into Manitoba. And the soils are also not great for flooding because they are clay and it is extremely flat. And they're also calcareous. So this is what the kind of flooding looks like up there. It spreads out across the entire landscape and covers fields. So there's quite a concern for runoff. The field trial we set up is corn soybean rotations with 8 phosphorus-based treatments. Some of them, though, are like having additional things in them like magnesium or zinc and different forms of sulfur, and that's just the products that farmers use. And it was based off what farmers are actually buying, and double rates were applied on some because one technique that farmers are doing there is they're trying to put down all the phosphorus for 2 years and then just not have to go back to that field, which is normal. But this trial is kind of testing out like how is that impact on water quality? Is that actually something we should be doing? And there's also nitrate mineralization going on in this field. And then we started a second rotation next to it. For treatments, we have these different rates. This is all in pounds per acre. And struvite or crystal green and the mez, like the Z in there is for zinc, have zinc or magnesium in them, as well as different forms of sulfur than just the straight up MAP, which is the ammonium phosphate. And these are very, very high pH soils. It's like 8.5, 8.6, and also very calcareous. And the lab study we set up was using field samples, grouping them like by replicate. So it's just sorted by treatment over an average. Putting water in the top of the little mesocosms and letting it set and incubate and measuring the release of phosphorus and the change in pH over time. Yeah, because it should be coming out from a fixed form and going into the soil water. So why is it different for crop recommendations in these soils? It's because the calcium and magnesium, as well as the iron in these soils, are affecting the secondary soil minerals and changing the cycle of dissolution and precipitation. So this area of Minnesota is just going to be really different. So in the simulated flooding trial, there is a significant trend in increase over time over like 8 weeks, as expected. And the highest ones were MAP at a single rate, which was an outlier because it matched some with a single rate that were also applied, as well as expected, the mez and struvite or crystal green. And this is the upper soil layer. In the lower soil layer, it was just kind of like all over the place, which was also kind of expected because it didn't infiltrate through as much. So for, the upper soil layer, any products that had the zinc or magnesium stood out as statistically higher. And then the outlier plot was one of the maps. That one we're kind of explaining so far by that in the randomization of the field, it's supposed to be all separate, but all those 3 were on one side of the field and they were where the plow loops around. It looks like there could have been some drag because they go through all these plots that have the mez and then they're all close together. And that's something I'm planning on digging into more. And then the lower soil layer was a little more all over the place, but was kind of trending up over time. It was different for the pH though, which I'll get to here. So thoughts for the orthophosphate part is that but besides the higher rates having the highest treatments having the zinc and magnesium added, the pH was also lower in those treatments in the lower soil layer statistically. And in general, when the soil pH increases, the availability of the phosphorus and zinc and iron decreases. So it's sort of implying a increase in phosphorus availability in some of the treatments. And what is kind of coming out of this for recommendations is Heidi and Lindsay at the Crookston campus have been working on like the Minnesota P index, and corn and soy, they weren't in the Red River Valley before. It was just too cold there. Now as they're moving there, the nutrient recommendations for Minnesota need to be updated or created to begin with for these crops. So this information is like can factor into like creating those recommendations for corn and soy as it moves north. And at the same time, there's also like increased major weather events, increased flooding that's becoming more unpredictable. Unfortunately for farmers, like a conclusion of this is kind of that it's better to apply one rate of phosphorus every single year instead of two, because there wasn't a difference in the corn yields, but it is coming out in the soil water at the double rates. So it's more work for farmers, but overall might be what ends up being a recommendation for water quality. And that's it. That's what we've been doing. Thank you.
Any questions?
Yes.
You guys talk to any farmers about these results, about how it's better to apply phosphorus every year rather than every 2 years? Because I'm curious what their reception or how receptive they would be to that suggestion.
Not yet.
Right. Great. Great. I think it's on the scroll.
Do you see any cases where you think the crystal being used right would be useful?
Well, it seems like it's useful at getting more of the phosphorus to precipitate out. So if that's a goal, it's just in this case, it didn't change the corn yields and corn yields. So it could be useful depending on the farmer's goals and what they're looking for.
Questions on that? Thank you, Rory. Our last presenter is Mimi Dunda. Dunda, sorry, thank you. I knew I was gonna get one of them wrong.
It happens all the time, honestly.
She's gonna share with us her poster.
Can I move this?
What you mean, the one that's been bugging you? Some technical help.
Oh. Let's see. Okay. Well. Oh, no. There we go. Okay. I've never been to one of these before, so I wasn't expecting this many people. But this is the poster I'll be presenting at the Midwest Cover Crops Conference next week in Indiana. So I'm just going to give you guys an overview of how this past season has gone and some like preliminary data that we have. So my project, well, let me introduce myself. I'm Mimi Dunda. I'm a first-year master's student. I'm working with Brent Dalzell, Jeff Strzok, and Anna Cates, and we're assessing the environmental benefits of a Kira Clover living mulch system, and also developing management guidelines for a Kira Clover living mulch system. So living mulch systems are being used in research to reduce soil erosion, water runoff, and improve soil health and water infiltration. They're also found to be they're also found to be good for reducing nutrient losses. And since they're living mulch systems, they're potentially a more approachable conservation system because they only need to be established once. So Kira clover is great for upper Midwest farmers because it's a winter hardy legume that is drought and cold tolerant. And it spreads through rhizomes, so it can cover a landscape really fast and also adds diversity to a cash crop production system. So for our project, for the methods, this might sound a little complicated as I'm speaking. I wish I had like a visual of the plot for this poster, but I don't. So for our site down in Rosemont, we had a plot with, a field with 24 plots. And we used two row establishment methods, which were strip tillage and banded herbicide to kill back the clover. And then with that, we used 3 planting dates, which were on May 8th. I don't know if you can really see it up here, but first one was May 8th, May 15th, and then May 22nd was the third one. And then we also had different fertilizer rates. So there was, within one plot, there are 6 subplots, and each subplot has its own fertilizer rate. So that ranges from 0 to 200 kilograms of nitrogen per hectare, and it increases by 40 kilograms, or increases in increments of 40. I think that pretty much covers how the plots were made. And so on November, I think that's it, yes. And then on November 2nd is when we harvested. So we took 1 row samples from each subplot, so 6 samples per plot, to account for the different fertilizer rates. And then also throughout the season from May to October, we took clover biomass samples. So now we're processing the clover biomass and the maize grain, stover, and cob for elemental analysis to look at nitrogen and organic carbon within the biomass. And then in like mid-November, a couple weeks after harvest, I took soil samples to look at soil health and soil microbial communities. So that's in the process of also getting assessed. So that's we're going to be using tests such as like PMC and microbial biomass to look at those and see how Kira clover has been affecting the soil health in that way. And some of our preliminary results compared to last year, they're lower. The average yield has been lower than our 2022 data, and that's most likely due to the drought conditions that we faced in 2023. So our plot was periodically irrigated, probably should have been watered a little bit more. Sorry. And also the Kira clover faced difficulties with weed competition. So we treated that with herbicide treatments. And then later on in the season, you can see in this graph, this is way too small for you guys to see, but the blue is 2022, and the red is 2023. So you can see that it drops off way quicker than 2023 did. And that's because not only was it recovering from these herbicide treatments, but there's also potential water stress. And then once the corn canopy cover came in, that also factored into how it recovered and reestablished. And so it didn't do, the clover also didn't do as well recovering like it did in 2022. So maybe there are some adjustments for how we manage that for next year too, and maybe some proactive measurements we can put in place to fight the weeds. And so the Kira clover has a standing chance against that. But yeah, so now we're just getting through processing all of our samples. And our plans for next year is we're establishing a new site down in Lamberton, which has tile drainage, so we can look at flow and nitrate leaching, which would be really great. We can add another aspect to this project and further develop our guideline or management guidelines, and I'm really looking forward to that. And that's kind of all I have right now. Sorry you guys can't see the graphs very well, but yeah, so this is our site in Rosemont. This is the 24 plots. And then this is right after they established the tile drainage down at Lamberton. And that's all I have. You guys have any questions?
Any questions?
Does any of these sites have irrigation on it?
The Rosemont one does, and I think we irrigated 3 times this season, which definitely wasn't enough, I don't think.
Still you see the decline in the.
Yeah, Yeah.
So there are experiments in West Florida, in West Central, where towards irrigate, and Fabian has this particular plot, and I have been irrigating those plots, and we have been irrigating like from last 3 years so much. Still, we see lots of stress, both in corn and soybean.
Yeah.
In over plots.
yeah,
So with changing climate, I'm like, I know it's very good for soil health, but in terms of, when you have to irrigate so much in these systems, how would that be beneficial?
right, yeah. That was definitely one thing that as soon as we harvested, we were like, okay, maybe we should have added this a little more frequently over the summer. But yeah, I'm also worried about that for this next season, just because we have no snow. So how is that going to affect everything for next growing season too? So that will be also interesting to see.
Is there any way to work around the cure clover being basically outcompeted by corn once it can't present? Can you do anything? Did it just die?
It mostly just died because of the herbicide treatment, and that was really it. And then, so that was like the first thing that made it like unable to reestablish. But yeah, the canopy cover, because there was so much shade, it was only in certain plots that it had so much shade. So those plots you really noticed that it couldn't come back. But I mean, the other plots where it was sprayed and like treated for weeds, it bounced back like perfectly. It was great. So if it doesn't have too much shade, it's fine. But yeah, the shade is definitely a factor as well. Thanks.
Thank you,
Okay.
Mimi. That's the end of our presenters. That should be all for today.